Okay, now we come to nature of electrode part 2. So this time we are talking about copper as anode. But before that, okay, we just want to make remarks for the last videos, okay, using mercury as cathode. First of all, you have to pay attention to the brine water, or sometimes we call it brine solutions. It is referring to saturated. Okay, remember, must be saturated sodium chloride solutions. Okay, this one is not equivalent to concentrate, not equivalent. Okay, so remember, not equivalent to concentrate sodium chloride solutions. Second one, okay, sometimes seawater will also be regarded as brine solutions. It can consider as brine water, brine solutions for seawater. But even it's like that, okay, it is not necessarily saturated. For seawater, it's not necessarily saturated, okay, but sometimes we could just call that brine water, okay. So once you ask about brine water, you use these terms, okay, saturated sodium chloride solution. Last thing is about the sodium dissolved in mercury. Okay, after they dissolve in it, we form an alloy, which is called sodium amalgam. Okay, yes, this one is in liquid state, okay, because the mercury is in liquid state. So the sodium dissolved in it, okay, it will just immerse with it and become a liquid state. So that's all for the last video. Okay, so before we talk about the using copper as anode, okay, we'll have to discuss a very similar electrolytic setup first. So this setup, we also use copper to sulphate as an electrolyte, but this time we're using graphite electrode. So very quickly, the very first step, okay, you have to use CAN, okay, so you got an negative side here, okay, so therefore this one is anode, cathode, anode, and cathode, okay. And then for the electrolyte that we have this time, okay, we will have copper to sulphate, okay. So therefore we will have Cu2 plus sulphate ion, you got H plus and OH minus. So to consider which one will preferentially discharge, first of all, we're referring to the ECS electro chemical series. So we will find that we have Na plus H plus Cu2 plus, okay. So from this side, okay, we found that, okay, Cu2 plus is a stronger oxidizing agent. So Cu2 plus will be one discharge, and for the other side, okay, we come across this many times, so it should be hydroxide ion. So we'll know that, okay, at cathode, Cu2 plus will then gain electron to become Cu, while at anode, 4OH minus will then become O2, H2O, and 4 electrons. Okay, I'm not going to write the overall equations. Okay, but basically based on this, okay, we can have a look of the observations that most likely happens. Okay, first of all, you will find that, okay, the Cu2 plus is getting less because they're going to form copper. So concentration of Cu2 plus decrease. The third thing that will affect will be the color of the electrolyte. So because Cu2 plus concentration is decreasing, so therefore the blue color of the solution fade. So this one is the first one. Okay, second than that, okay, you can also see Cu. Okay, so therefore you may observe reddish brown solid deposits at cathode. Okay, so last things, okay, we'll also see some colorless gas bubbles form at anode. Okay, so we'll see some colorless gas bubble form at anode. So things, it will be more or less like this. You have solid form, okay, you got bubbles here, okay, and then this one will get fades. Okay, so the third one, okay, is a colorless gas bubbles. Oh, I'm not going to write too much for this. Okay, so you'll find that, okay, this one, okay, is based on the preferential discharge, okay, in the ECS, okay, or position in ECS. Okay, we're going to find that Cu2 plus discharge and OH minus. So funny thing is you have to pay attention to of the Cu2 plus discharge and OH minus discharge, leaving behind, okay, we got H and SO4. So therefore the final solution will become H2SO4. Okay, after a while the copper to sulphate will then become the sulphuric acid. Okay, so this one, okay, is about using graphite as the electrode. Second one, okay, we come to the focus of this videos. Okay, so this time, okay, we are using anode are using copper as the anode. Okay, so you find that, okay, in this setup, okay, both of them we are using copper. Okay, but anyway, okay, we'll just have a look of the ACAC, identify the ACAC first, okay, and then we're going to have the cathode anode. So you'll find that, again, we got sulphate, we got water. So for the cation part, okay, it's pretty easy. Okay, we'll find that Cu2 plus is more reactive. It's a stronger OA, okay, so Cu2 plus will discharge, okay. But one thing you have to pay attention to the anode part, okay, because this time, okay, we are having Cu as well, okay. So even right there, you got sulphate, you got hydroxide ion, okay. So you got these two things ions, okay. OH minus seems more reactive than the sulphate ion. It seems it will go to discharge, but you'll find that, okay, this time, okay, other than OH minus, we also got Cu itself. This one is not an inert electrode. So if we're referring to the position ECS, you find that Cu actually got a higher position than OH minus. So therefore, Cu should be a stronger reducing agent. Okay, so remember, Cu has a higher position than OH minus ion. Therefore, Cu is a stronger array. So you'll find that, okay, this time, okay, we are having Cu to discharge, okay. So let's see, okay, how the equation is going to write. So at cathode, Cu2 plus is going to gain electrons and become Cu. While at anode, the Cu will be the one discharged, and in the process, they will also give out electrons, forming Cu2 plus. If we try to write them together as a full equation, you'll find that one funny thing is all the particle in it, Cu2 plus, Cu, electron, they will cross out everything. So in this case, how I'm going to write it, okay? So we'll write like this, okay? Cu becomes Cu, because it is not really not having any reaction. If you look at the setup, you'll find that, okay, at the cathode, you got more copper on it. So therefore, you see that Cu2 plus will get on it, okay, and get thicker for the electrode. While on the anode part, okay, the Cu atom, it will become Cu2 plus. So therefore, getting thinner and thinner. Okay, so actually we do have a reaction there. Okay, in order to represent this one, okay, we can write Cu. Okay, we can see that, okay, actually the copper is transferring from anode to cathode. Okay, so once you lose in anode, you stick on cathode. Okay, so we'll say Cu at anode will become Cu at cathode. So it is pretty easy for you to memorize, because if you pay attention to, okay, from A to C, okay, A, B, C, okay, A to C, okay, so therefore is from anode, okay, the copper will dissolve, okay, and then form on cathode. So what observation we can see, just as we mentioned one already, okay, we'll find that the anode will got decrease in size, while cathode increase in size. And or you can say that it's get thicker, and this one get thinner, is also okay. Okay, but one thing is, okay, if you're referring to the equation, you find that one Cu will then become one Cu atom will then become one Cu at cathode. Okay, from anode will become at cathode. That means it is 1-to-1 ratios. So we will say that the mass of anode lost will then equals to the mass of cathode gain. Okay, so this is one very important observation that you can have to say. Okay, while the other one, okay, it will be related to the color. Okay, so you know that copper 2 ion is blue in color. So this time, okay, how will the color change? Okay, so you'll find that every time when at anode, okay, there's one copper losing one Cu2 plus ion, one Cu2 plus ion will then jump on the cathode. So therefore, one out, one in, one out, one in. So every time the Cu2 plus ion's number should be the same. So how do we going to say this one? Okay, so we can say like this. Just get space to write first. Okay, so we'll say that, okay, for every Cu2 plus ion discharge at cathode, one Cu2 plus ion form at anode, because concentration of Cu2 plus ion remains unchanged. The intensity of the blue solutions will then remain the same. So this one you can see that, okay, they have all difference, okay, from the previous setup. The previous one, without copper as the anode, the color of the blue intensity of the solutions will fade. But for this one, because the Cu2 plus ion keep replenish from the anode, okay, the copper atom keep on releasing copper 2 plus, okay, to replenish the lost one. So therefore, the intensity of the blue solutions remains the same. So this setup mainly, okay, you have to know that, remember, okay, the copper, okay, from anode will losing some copper atoms, but it will form at cathode. And in the process, okay, you can observe that the anode will decrease in size, getting thinner and thinner, while the other side will get thicker. The mass loss in anode will be the same as that in cathode. Okay, and also the color change, okay, because of the Cu2 plus ions, the concentration remains unchanged. Therefore, the intensity of blue solutions remains the same. So, one more thing I just want to remind you, okay, is about the changes in the electrolyte. So you can have a look of this. Okay, so right here you find that Cu2 plus keep discharging. Okay, but for the copper one, okay, they keep on producing new Cu2 plus here. So you find that, okay, the Cu2 plus ion actually it is the same, okay, all the time. So therefore, for this setup, okay, the electrolyte actually they remains more or less the same in terms of concentration, or whether they will change to other substance, okay, they are the same, okay, after the reactions. The only difference is the size of the electrode. So to wrap up, okay, so our two electrolytic setup, the first one with graphite as electrode, with graphite as electrode. With graphite as electrode. Okay, first of all, you have to remember for this one, the cation losing electrons, okay, will be cation to react will be Cu. Okay, so therefore you can see some copper reddish brown solid, okay, deposit at the cathode. While the other side, okay, OH minus is going to discharge, become oxygen. So you can see some colorless gas bubble forming at the anode. Okay, and after that, okay, you find that only H plus and SO4 minus leaving behind. So therefore this one, okay, they will change to sulphuric acid eventually. Okay, but for the electrolytic setup of copper sulphate with copper as anode, the other setup, okay, will be slightly different. So for this setup, you'll find that the Cu2 plus they will discharge, but on the other side, okay, no matter it is sulphate or OH minus, okay, they won't discharge because Cu is a stronger Ra than OH minus and SO4 minus. So therefore, Cu at the anode, they will discharge and release Cu2 plus. Because the Cu2 plus, discharge at the cathode will be replenished by the Cu2 plus released from the anode. So therefore, very important thing is Cu2 plus concentration is the same. So therefore, the intensity of the blue color of the solution is the same. So this is one of the very important observation. But for the one above, Cu2 plus concentration, it keep decreasing. So therefore the blue color fades. So this one is a very main difference for that. And other than that, okay, you have to remember, Cu at anode will become Cu at cathode. So therefore you will find that the mass lost in anode will be the same as mass gained in cathode. Okay, so the observation, okay, better not to say things like this, okay, this one just to remind you. The observation will then be like at anode, the copper will become thinner, or while at cathode, the copper will become thicker, okay, they will increase in size or increase in mass, okay. So that's all for this video. Bye bye.